So I got this thing. It's a little CNC router from Amazon. I put it together in about an hour, and I'm making a PC board. As you can see, it's doing the cutouts now. I already had some of these little end mills here, and I ordered some of these little engraving bits like that with it. And this is kind of what I'm after. This is the first one that I made. It's kind of rough, but it actually did work. But I have to replace these diodes with these diodes. So I'm remaking it where the holes are bigger and there's a little bit more space between them. And the traces aren't that big. And I need them to carry a little bit more amperage. So I'm making a new one with bigger traces and things like that. So this, seeing as how this is the first time I've ever done one, I thought it turned out okay for the first one. The idea is you have 4 24-volt things coming in. Each one of them is split out using these diodes. So you'll have one input come in here, and then it splits out. One goes one way, one goes to this. So each one of these diodes go to one of these 4 relays here. The 5th relay is hooked into here, and they're sort of daisy chained together. And essentially, if any one of the inputs that would be here, 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 and here were to go out, one of these relays would go out, which would change the state of this relay. And essentially what it is it's a redundancy circuit. And this is just my way of tackling the problem. And then out these 4 diodes, so these act kind of like one-way valves to some degree, they all go back to one source. So you'll have one tap in here where even if any one of these 4 sources were to die, you've still got 24 volts. So essentially the way it works is you have 4 converters that are converting 48 volts to 24 volts. And if any 1 or 2 of the 4 die, the other 2 still have enough to feed the circuit that it needs to feed. So any 2 of them can die, and the other 2 can carry the load. And the idea is, obviously for redundancy. And then this, if any one of them were to go down, it trips this other relay, which this would be hooked to this on the outside of the box. So you would be able to connect your alarm setup to this. And when this changes state, hey, my 24 volt converter just has a problem. But it hopefully will continue to run on 3 or 2 of what's left. So the idea is this is going to let you know, hey, you got a problem. Really, really simple. Nothing amazing about it. But it took me a while to learn all the software and all that kind of stuff. I've got a CNC mill, but the G-code wouldn't work for it. So it was simpler and faster to just buy this thing. And actually, I'm kind of enjoying messing with this thing. It's actually pretty cool. If you were just getting into CNC and wanted to learn it, this would give you the basics. And what you learn here, you could take to a bigger, faster, better machine. So, got a chatter. But really, you could even do some milling to some degree with this. It don't have a lot of Z-stroke, but you could kind of play with it and learn on this. And, it was $150, I think. So worst case scenario, you buy another one. If you break it, you can buy a whole nother one for $150. It'd be a great learning tool to learn CNC. The software is free. This is Universal G-Code Sender platform, something like that. And it took me a minute to kind of figure this out. Took me a minute to figure out how all this stuff hooks up. And there's actually, I have some limit switches that it doesn't come with. I just happen to have those. And I'm going to put those on this. And this software can read the limit switches. And that's where you hook your limit switches into. I want to know what this connector is. If anybody knows what type of connectors these are and how you would install them, I want to be able to make those so I can do this. But I'm actually sort of looking at this as a test bed too to make some other automation stuff. So this is GRBL, Gerbil software, I think is what this is running. It's free. You can run it on an Arduino like this one and basically run a whole CNC machine off of that, from what I understand. So anyway, I just thought it was interesting. It didn't take me long to get this up and running. It didn't take me long to get the software together. It literally took an hour to assemble this. Now, one of the problems I did have is this hole right here, where that's spinning. You can see the lead screw spinning inside of there, and you can see how rough that is. I had to take a Dremel and just work my way around that, because what was happening is while this lead screw was spinning, it would sort of go back and forth and it would lose steps because it would get stuck. It was like it was screwing into itself right here because they didn't make this hole quite big enough, and the threads were literally trying to screw into it and pull away from here, and then it would overpower the motor. So the motor was just, it couldn't do anything with it. So once I did that, fiddled with it a little bit, took me another hour to figure out what was going on and to fix the problem, but still, I think it worked out pretty good, and the accuracy is pretty darn good. I've been impressed with it so far. And the lead screw mechanism, which is really neat, is you've got a lead screw, or a screw, a nut here, and then a spring and another nut. So it actually keeps it, you get rid of your backlash like that. That's a really simple way to get rid of backlash. I thought that was pretty cool too. So I'm thinking I might design a plasma table using a similar setup. So anyway, I just thought it was kind of cool. If anybody wants any information about it, ask me. You can also add a laser engraver to this, and I bought one for one of those 3D printers, so I may see if I can wire it up to here since I've already got it, and do some of that too. So anyway, you guys have a good day. Bye.